This is the gamma radiation of 60 keV gamma rays from Am241, American 241, from a smoke detector 1 microcurie source. You can see on the scale there, getting an average reading perhaps 0.6, 0.7 microsieverts per hour, 0.8 microsieverts per hour. So this is an Thermo Eberline ESM. It's a gamma survey meter, and if we take a look at it, it's got a NATO part number 6665123264538, and it's got a chirper, loudspeaker control, can be turned on and off, light, a switch there which can turn it to Geiger count, where it counts the number of individual clicks, or you can, by pressing various combinations of buttons, you can get the total dose. What we're doing here is just measuring the dose rate from the smoke alarm radioactive source. Now, if we take the source away, you can see the count fall down. It gives you an idea of the response time and the background radiation level. It's slowly decreasing the count rate. As I say, these radiation counters are sensitive to gamma rays, as you can see there on the information, 45 keV to 1.3 MeV. This is a small Geiger tube located inside the case of this instrument, which is a handheld device, which is a bit bulky, but it will fit in your pocket. It works on one 9-volt battery, the small type of 9-volt batteries. And you see, if you see here, it will measure up to 9.99 millisieverts per hour. Now that's, to convert to milliroentgens per hour, the old unit, you multiply by 100. So that's basically measuring up to just under 1 roentgen per hour in old money, old units, or 1 rad per hour to be to use the energy unit. Now, sieverts are biological units, so this is not a Geiger counter. It's not really measuring sieverts. It's really measuring in roentgens, in ionization units. So the idea of taking a Geiger count and measuring, trying to convert that into a biological equivalent unit is a little silly, but that's what they do, and it's approximately correct, provided you know what you're doing and you know that the radiation dose inside bone marrow is only going to be about 2/3 of that in the air, because of the shielding by the surrounding tissue, and it's the bone marrow dose that determines the leukemia risk, for example. So you have to know, how to use the instrument and how to interpret the readings correctly. So you can see here the radiation count is way above background. The reason is that the radioactive source is only about 10 inches away. If we moved it further away, the reading would gradually decrease further. It isn't slowly going down. Of course, there's a sort of randomness in the count rate. Each click is one count, and that can be caused by a neutron knocking a proton off a hydrogen, out of a hydrogen atom, and that proton then causes ionization in the Geiger-Müller tube, or it can be caused by a Compton electron knocked off by a gamma ray. So there's various sorts. Now it's going down to typical background. The source is about 4 feet away. We're getting 0.1 microsievert per hour, which is natural background in London, England.